Okay, this is the last page of the practice exam for midterm 2. And there are 4 problems here. The first one is to evaluate this limit. This limit involves a square root. This should be very similar to the one we did in class. The thing that should pop into your head is to multiply by the conjugate. So you got to multiply by the conjugate. The conjugate here is square root of x plus 2. And the whole point is we are forcing a difference of squares. So square root of x plus 2 on the top and the bottom. And that forces on the bottom a difference of squares. So this will be equal to the limit as x goes to 4. On the bottom, we have a difference of squares. We have square root of x squared is just x, and minus 2 squared is 4. So the bottom becomes x minus 4, and the top is this multiplication. And this is where the miracle happens. The top and the bottom perfectly cancel out. X minus 4 on the top and the bottom, those cancel out to give you this nice limit, square root of x plus 2. So by multiplying by the conjugate, noticing the difference of squares, and canceling, you simplify the limit, and it no longer is a type 0 over 0. So to start with, it was a type 0 over 0. If you had plugged in, you would have gotten nothing. You just would have said type 0 over 0. We got to do more work. This whole shebang of multiplying by the conjugate is the trick to whoosh away the 0 over 0-ness. And now we have a limit that is perfectly fine. Now we can just plug in because it's a continuous function. And we get the square root of 4 plus 2. And the square root of 4 we know is 2. So this is 2 plus 2, also known as 4. So final answer, 4. Final answer, 4. Oh, my face is blocking it. There you go. Final answer, 4. Okay, this one is extremely similar to the one we did in class. If you want to see it in more detail, go watch the video where we did that one in class. Find the number of terms and the sum of the geometric series 4 plus 8 plus 16 all the way up to 1,048,576. And you got to notice here, these are always powers of 2. We start at 4, we multiply by 2, we multiply by 2 again. So to answer this question, I think it helps to answer the question, how many times do you have to multiply by 2 until you get to 1,048,576? So let's see, how would I do that? I think I would write these as powers of 2 and just see how the powers of 2 go. So 4 is 2 squared, 8 is 2 cubed, 16 is 2 to the 4. So every time we multiply, the power of 2 is going up by 1. Which of course, in general, it's a times r to the n minus 1. You multiply by r every time. And it just so happens here that like the a value is also a power of 2. So it's all a power of 2. Actually, okay, why don't we do it? Let's do it in general. Let's write it like this. Let's write everything like this. This is 4 times 2 to the power 0. That's this one. This one is 4 times 2 to the power 1. This one is 4 times 2 to the power 2, and so on. And now we really see this structure. A equals 4 and r equals 2. It's going up by 2 every time. What is this one? Well, it's 4 times 2 to the power n minus 1, right? Where n is the number of terms. So I got to solve for n. 4 times 2 to the n minus 1 equals 1,048,576. Let's divide both sides by 4. 2 to the n minus 1. 1,048,576 divided by 4. And now to solve for n, I'm going to take the log base 2. Log base 2 of this stuff. And if you take the log base 2, you're going to get n minus 1. So the log base 2 undoes the 2 to the power. Taking the log base 2, you just get the exponent n minus 1. And on the other side, you get the log base 2 of 1,048,576 divided by 4. That's definitely not one you can do in your head. We're going to go to the calculator. Calculator. All right. So we got the number 1,048,576. We divide it by 4. That's this thing on the other side. And we want to know what power of 2 would give that. And do I have a log base 2 button? I don't. Okay, so how am I going to do this on my calculator? The log base 2 is the log, when I use this change of base formula, the log base 2 of x is the ln of 2 divided by the ln of 2. It's the ln of x divided by the ln of 2. This is the change of base formula. And in my case, I got this wonky number, let's do the ln of this. And then I'm going to divide by the ln of 2. Well, let me do this. 2 ln. Okay. 18. There we go. It worked. This is 18. So I had to do the log base 2 to figure out what power of 2 is equal to this. And I used the change of base formula because my calculator didn't have a log base 2 button. I highly recommend you check out your calculator before the exam. Does it have a log base 2 button or not? How would you do this type of calculation? So we have n minus 1 equals 18. Nice round number. And therefore n equals 19. N is 19. So there are 19 terms. 19 terms. And as a sanity check, just to make sure everything went perfectly right, I'm saying this is 4 times 2. 4 times 2 to the power 18. 4 times 2 to the power 18 is supposed to be 1,048,576. Is it? As a sanity check, let's check it out. So we'll do 2 to the power of x to the power y, 18, times 4, 1,048,576. So everything I did is correct. This equation that I solved for n, it worked out. The answer was n is 19. So there are 19 terms over here. What is the sum? To do the sum, you got to know the formula for the sum of a geometric series. We used the infinite version already a couple questions ago. The version for a finite sum should also be on your notes. The sum, I believe the formula is a times 1 minus r to the n divided by 1 minus r. I'm trying to think if it's an r to the n plus 1 on the top, or is it an r to the n? I think it's an r to the n. Yeah, it's an r to the n. Okay, so in our case, this is 4 times 1 minus 2 to the power 19 divided by 1 minus 2. And you could leave it like that. If you want, you can plug it in your calculator. Let's do it in our calculator. The answer is going to be, after simplifying, I'm going to put it all the way over here because I'm out of space. 4 times 2 to the power 19 minus 1. Right, because the bottom, 1 minus 2, is just a 1. Well, a negative 1, and that's why the top flipped as well. But 4 times 2 to the 19 minus 1. Okay. 2 to the power, nope. 2 to the power 19, minus 1, times 4. So 2,097,148. There you go, that's the sum. So it's approximately twice the last term, right? Which is how these sequences of 2 go. All right, that was that one. Again, really the question is solving for a and r and n, and then once you know a, r, and n, you just plug into the equation. Okay. 2 questions left. I have to go, but I will make another video with the last 2 questions in a bit.